Welcome into another episode of Everything is Logistics, a podcast for the thinkers in freight. I am your host, Blythe Brumleve, and we are proudly presented by SPI Logistics. And speaking of logistics, we have another incredible episode for y'all today, and we are talking about deep space logistics. Now, this conversation comes from a recent tour that I was given, a behind-the-scenes tour, lucky me, over at NASA for one of their social media programs, basically PR, branding, outreach, that sort of thing. Not that NASA needs any kind of branding or brand awareness. But they have a program called NASA Social where they invite a small number of creators to come get a behind the scenes look as to what goes into a NASA launch. So this is one of several episodes that we recorded on site while on the 2-day tour over in Cape Canaveral, Space Coast, which is about 2 hours south of my hometown, Jacksonville, Florida. And so for this particular episode, we are going to be hearing from Matt over at the Deep Space Logistics Program. And he's basically going to be talking at length just how we get things up into space. Are there trade lanes in space? Getting supplies to and from, the challenges around that. How do you even prepare, for a launch? What kind of supplies go on, a rocket versus a transporter mission, which, a transporter mission is just basically only sending goods, no astronauts. And so, he gets into all of that. It's a really interesting discussion. And then he rounds out the discussion with a lot of Q&A. And of course, I had a bunch of questions being the logistics nerd. So it was definitely one of the most enjoyable conversations and one of the most lengthy conversations that I was able to record while on this tour. And I believe it's about 26 minutes long. So hopefully you will enjoy this episode, and I'll see you on the other side.
Contract that we issued for the Deep Space Logistics contract. We're planning on onboarding another spacecraft. The objective of this is for a commercial launch environment or commercial resupply environment for deep space. Starting with the moon and then working on our way on to near-Earth objects in Mars, Venus, wherever we need to go. So it's really just establishing a deep space supply chain. Up until this point, we've had other commercial endeavors here at Kennedy Space Center. So commercial resupply service for International Space Station. Northrop Grumman has the CRS vehicle, their vehicle. There's also the Cargo Dragon from SpaceX, along with others. We've also had international resupply services from JAXA, which is the HCV vehicle, and the cargo resupply from ESA as well. And the name eludes me, but there was a whole bunch of these things. So we've established a resupply service for the ISS, which is above us, flying around at about 300 to 400 kilometers. It's about 7 to 9 kilometers a second, depending on where you are relative on the Earth. If we're trying to go further, the moon is much, much further away than low Earth orbit. It's a much more difficult environment. The orbit that we're going to is very elliptical, very unusual, and so it provides a lot of challenges for us, a lot of things that we didn't have to face with ISS. The first of which is a lag time. We have to have a lot of autonomy with the gateway that we didn't have to do with ISS, because there's always people on ISS. There's no communications delay, it's right above us, but when you're dealing with something as far away as the moon, that 2-second delay can mean a crash and a successful dock. So the vehicle is going to have to learn and adapt by itself, and this has provided us with a massive challenge. Analogy to this would be if you wanted to program your little robot to, for example, come down this road and then take a right turn and park by the couch. You know exactly where the couches are, you know how far it is from start to finish, where it needs to turn, how far it needs to turn, and where it needs to get there. But imagine if you weren't exactly sure where that corner was. You knew you had to do a right turn, but you weren't exactly sure where. So you have to have that robot have a sensor to measure where the couches are. It's not going to be a perfect measurement, and it's going to have to update that and update its estimate every time step. So imagine this not just in 1 degree of freedom, but in 6. And that's the challenges that we have to face with ISS. In addition to just ISS Gateway. In addition to this, Gateway is a lot smaller than ISS. So as we have our logistics vehicle coming in close to the Gateway, it's about this big, so it's about 1/6 of the size of where it's docking to. So when it slows down, it's firing those jets. You ever see jets take off from the aircraft carrier? You have that big panel that comes out, the jet blast deflector, to make sure the crew doesn't get blasted off the deck of an aircraft carrier. That's the force that these jets are generating. So imagine coming up to a ship and you're blasting it with your jets. You need to slow down, but you're also pushing your ship away. So there's this coupled relationship between your ship and the space station. And so it's constantly pushing and pulling. So this is another challenge that we're trying to deal with. In addition to that, we have these roll-out solar arrays here. On ISS, these solar arrays are fixed. They're made of silicon, they're rigid, and they can be buffeted and they move and they wobble. But these solar arrays are roll-out. There's a single stick in the middle, and they roll out, fold out like a, almost like a sheet, or like a shade, right? And so these are going to wobble and flex all the more when you're blasting them with these jets. So that's really what we're dealing with right now, and that's a lot of the challenges that I deal with. In addition to that, I work a lot with lunar environments. So the lunar dust, as you might know, is very dangerous, very abrasive. Astronauts bring it in, they get something called silicosis, which erodes the lungs. It's also very sharp and abrasive, so if you get that in any moving parts, it grinds down those gears and makes them pretty much useless. So the longest time we spent on the lunar surface prior to the Artemis program was a total of about 73 hours during one of the Apollo programs. And by the time they came back from the 73 hours, everything was dirty, broken, and falling apart. So it's amazing that no one died during the Apollo program, at least in space. So some of that dust is eventually going to be cleaned to the outside of Starship. We did some tests with various materials, especially untreated aluminum. We spun that up to 400 Gs and the dust didn't move. So this dust sticks onto aluminum, wedges in the cracks, and the G-force is not enough to pull it away. So it's going to survive the launch environment from the lunar surface to Gateway, and we're worried that when it docks, it might transfer some of that dust because the charge dynamics are more powerful than the gravitational field in orbit. Of course, the gravitational field's relatively weak. So that's just some of the challenges. There's also thermal challenges, there's radiation challenges, there's optical challenges. If those surfaces get covered by lunar dust, how are you going to dock? Are you going to have enough clearance to dock because you're using optical sensors to dock? Is it going to damage the docking mechanisms? Is the resupply service going to carry enough oxygen and nitrogen to resupply the habitat? The micrometeoroid or orbital debris environment in North orbit, as you might know, is very dangerous. But in the moon, it might be less frequent, but they're traveling much faster. So where we might have stuff flying around at 11 kilometers a second in North orbit, they're 20 to 100 kilometers a second out by the moon. So if one of those punctures, you have to have stronger, more durable materials that can handle these very rare, very small, but very high-speed punctures. And then salvage the space station in the event of catastrophic failure. There's no emergency return for the Gateway, as there is with the ISS. In the ISS, you can come back to the Earth's surface in as little as 90 minutes. But you're up, if you have a catastrophic event, you're stuck up there for at least 3.5 days, but probably closer to a week, week and a half. So it's a lot of moving pieces. It's a lot of ways that our astronauts can die, and we don't want them to. So questions? I guess I'll pick it now.
So I'm hearing you mention like a lot of challenges and problems. I was wondering how you kind of like go through these problems or discover them. Like obviously there's some of it that you guys have experienced before with the ISS, but this is a completely different kind of mission. What more problems are you expecting? And then how do those problems affect your kind of timeline for this development?
So sometimes I wish our engineers understood that this is a completely different kind of system, because we have a lot of people coming in from the ISS that are very experienced, very knowledgeable, and very talented, but there's a tendency to try and roll over ISS methodology into a completely new system. And so that's usually where we identify these problems, is that we try to use old methodologies to solve new problems, and then we have some kind of disconnect. And we run some analyses, and it's like, oh, look, this is terrible. For example, we did the first analysis of Starship docking to the Gateway, and it's spinning. It's just tunnel. So we had to take a step back and like, okay, let's figure out how we're going to fix this. So it's a lot of analysis. It is a ridiculous amount of meetings. However meetings you imagine that we have to sit through to make ISS or Gateway a thing, probably double or triple that, because it's going on constantly. And usually the calendar has 2 or 3 meetings going on at the same time, and you have to pick and choose which one is closest to your expertise to sit in. So lots of talking, lots of, I think it's a lot of a very candid work environment. So there's always egos going on, but I think NASA is a pretty good place where if someone says this is wrong and this is why, people are more receptive to that. Whereas I think if you do it at a company, it's all about dollars and cents. And so it's like, no, that's too expensive. Granted, that does happen at NASA as well, but not to the same degree.
Are you in freight sales with a book of business looking for a new home? Or perhaps you're a freight agent in need of a better partnership? These are the kinds of conversations we're exploring in our podcast interview series called The Freight Agent Trenches, sponsored by SPI Logistics. Now, I can tell you all day that SPI is one of the most successful logistics firms in North America who helps their agents with back office operations such as admin, finance, IT, and sales, but I would much rather you hear it directly from SPI's freight agents themselves. And what better way to do that than by listening to the experienced freight agents tell their stories behind the how and the why they joined SPI. Hit the freight agent link in our show notes to listen to these conversations, or if you're ready to make the jump, visit spi3pl.com. From a cargo perspective, I get like fuel and oxygen and things like that, but what are some other items that you're regularly shipping up to space? And then what are maybe some backup items?
So that's a very good question for logistics. So Let's start with this. So there are two types of deliveries that we have at the gateway. One is what we call a fast transit, which goes from the surface of the earth to the gateway in about 3.5 minimum days, usually about a week, to do all the flybys and burns. And then we have a slow transit, which means we can deliver more cargo over a long period of time. And what we do is we come from Earth, we have this big slingshot of the moon, because the Earth is orbiting the moon. So we use that momentum and fly into space, and then we slow down out by the sun, and when the moon has come back around again, we can use its energy to slow us down and put us into the orbit that we need to go into. And so by doing that, we can handle more cargo, but you're also in space for 180 days in a pressurized tube being blasted by radiation. So you have to consider what you're transporting. Is the food in a radiation-safe container, and how long can it last in orbit? Because if you're delivering food, it might be a problem. If you're not delivering food, you're delivering outfitting equipment for gateway, payloads for the power payloads for the power payload racks, or maybe you're delivering astronauts' diapers. So they wear diapers on the lunar surface because they're out in EVA for 8 hours at a time, or uniforms, or toothbrushes. Then you might be all right floating around for 180 days. So there's the standard consumables that you might expect: food, water, Norris tanks, nitrogen, oxygen resupply service tanks, and then there's, like I said, toothbrushes and consumables. There's other things that the astronauts have to work on a regular basis. So there are parts that are designed to be replaced after a certain amount of time so they don't fail. So these are standard maintenance stuff that you have to do with Gateway, just as we do with ISS. What else? The toilet. We're delivering the space toilet, and that goes up with every mission currently. That's kind of what we think we're doing. Still in movement. We might have a permanently mounted one later on, but that's what we're doing.
What about like female hygiene? Because I heard like the first woman that went into space, she was sent with like, women will get this. Yeah.
So there's actually, I mean, it sounds like it was a complete ignorance, right? And in a way it was, but it wasn't, I don't think it's painted quite the right way.
I heard like 1,000, so 100 is a little bit better.
Yeah. I exaggerated. Yeah. I don't know what the number is, but we strictly did not know what the female body would do in space. And so it's
interesting.
better to have an extra amount than not have enough. And that's the same case. I mean, you've got to think when the Apollo astronauts came back from the moon, they were quarantined for 2 weeks because we were worried there would be space germs and that they would contaminate all of Earth, even though there's an asteroid impacts the moon and we're contaminated with lunar rocks all the time. So there's always this extra step of risk averseness that we take to provide too much. They'd rather have too much or be too safe rather than not enough. But I don't know specifically how many we're sending up. I think we have a better understanding of biology at this point. So I wouldn't expect an entire Ellen Globin.
I would imagine that's a lot of space that takes up.
Quick question, and you might have already said this, and I just did. Is only NASA operating Gateway, or are other space agencies taking part?
Good question. So Gateway is an international effort. So Maxar, which is this one here, this is the power and propulsion element, and that's made by Maxar, which is an American company. And then Northrop Grumman is manufacturing the Habitation and Logistics Outpost, which is their first habitat. After that, it gets more international. We have the Esprit refueling module, manufactured by the ESA, and then the International Habitat, manufactured by the ESA and JAXA. In addition, JAXA is sending a resupply service called their HTV-XG, resupply cargo, just like the LM. They're actually working with it very closely. I'm going to Japan next week, as a matter of fact, to meet with JAXA to talk about this. And then we have the recent new addition to our international partnership, which is the Mohammed bin Salman Spaceport, which is the UAE participating in building the airlock module. So it is currently international. The airlock was originally slated to go to Russia, but there's been a
An issue.
And so we've given it to the UAE instead. We're always looking for more international partners to participate, especially with science payloads and other research opportunities. Of course, the lunar base on the surface is still wide open for participants to collaborate with us and make that work.
Will there be lab facilities or lab module?
So it is, the whole thing is a flying laboratory with a few rooms to stay in and sleep in. To say there's a dedicated laboratory, not necessarily. Everything's multi-use. It's a lot smaller than the ISS. The ISS is about the same size as a 6-bedroom house. This is about the size of a studio apartment on the inside.
Wait, go back to what you said
Yeah,
about
the
your house.
ISS is a 6-bedroom house.
It's about a 6-bedroom house on the inside, yeah. So this is the ISS here. Right behind you, you can see humans relative to Gateway right there. They're crawling around on the airlock module, like literally right behind you. So that'll give you the scale of what humans are to Gateway. And of course, the inside of that volume is mostly filled with cargo. So you have this passageways, and they have a closet, which is the logistics module. So there's some space to move around and to stay in. But really, there's not that much. That being said, if you look at the room we're in right now, it might seem like a decent-sized room, but when you remove gravity, you have all this stuff available above you. So small spaces tend to become a little bit bigger in space.
The reason I ask is just curious as to, I realize the purpose of Gateway is different than the purpose of the ISS. Just wondering how much of it will be used for research, because again, you're in an environment that we haven't done yet, like you're orbiting the moon. So we're gonna have to retest a lot of the things that we found out through testing on the ISS. Like, I was just curious about some of the instrumentation that might go in it. Is there someplace I can look that up? I go to NASA.gov, I haven't found anything like that.
There is.
You can get back to me if you like.
Yeah, well, I'm going to get back to you. There is a place that covers these scientific instruments. It's not easily found yet because I think part of that is because there's still a little bit of uncertainty.
Gotcha.
There are a few experiments that we know are going up. One tests radiation over time, and there are several radiation sensors being placed inside Gateway. There's also a materials testing bed, which will be on the outside. And there's a ton of sensors. I'm not a human factors
One of the
person.
things we're trying to apply is the Hermes pit experiment. You can Google that, it's all over the
Thank you.
Hermes, H-E-R.
Yeah, I'm
Oh, okay, very good.
So it's a lot of human factor stuff where the biggest priority is making sure our astronauts are going to be safe in a different environment. So that's the biggest priority. A lot of those things go into that. As a GNC engineer, I'm not intimately tied into that, but lots of that.
Thank you.
So I was wondering about, obviously you guys mentioned sending people back to the moon and experimenting in, lunar orbit. I imagine you guys have many future missions planned and operations. Like, what's the kind of timeline look like for how this is going to be used over time? Is it going to last as long as the ISS? Is it a temporary kind of thing until you get something better over there?
So there's two approaches to that. One, when is that? We do have a notional timeline, and that carries us up to 15 years, and I think it's like Artemis 11 or something, and that's what's available out in the public, right? We have this timeline that lasts about 15 years. There's also a possibility of extending that. The main purpose of Gateway is it's a moon to Mars thing, right? So this is basically our Mars spacecraft, our interplanetary Mars spacecraft prototype. We're learning what works and what doesn't work. So the short answer is it should last 15 years, but it's a big investment, and just like most of NASA projects, it's reasonable to expect it's going to be extended at least a little bit.
Do you know what the current schedule is when Gateway is supposed to actually be up there? And do you think that that's realistic and it's actually going to happen at that time?
There's a couple ones. I mean, there's the one that we currently have in the public, and then there's the working model, which has that schedule slip to the right, and that's just the nature of space exploration and technology development. So the one in the public, it's optimistic. Not super optimistic, but optimistic. Things are going to keep moving around, and really that depends on the progress of things like Starship, which is a huge unknown right now. That's our first human landing system. It's making tremendous progress. It's moving very quickly, but there's a difference between having a re-entry system on Earth and having something that can land our astronauts on the moon. We've seen recently that we've had a lot of landers. Think of Apollo, right? It was short, it was squat, it was wide. So it didn't really tip over. The past two landers that have gone to the moon have both tipped over. Because we're underestimating the challenges of keeping something upright in a low-gravity environment with unknown surface features. So something like Starship, which has a very flat bottom, needs a very flat surface. So that's just one example of something we're concerned about that we needed a few test demonstrations to make sure that we're doing. Not saying they can't, of course, everything's possible. It's just a matter of technological progress, how quickly they can test, how quickly the FAA lets them test, how quickly we can clear the water so that when it's splashing down the ocean, it doesn't kill anything.
And how do you test a lunar landing? Like, is it real all simulations, or are you building an environment that facilitates coincidence? Like,
yes to all the above.
Okay.
We have high fidelity computer simulations that test lunar landings. Thanks to the Lunar Reconnaissance Orbiter, LRO, Lunar Reconnaissance. We have a very high fidelity map of the South Pole lunar surface. So we know what that environment looks like, and we have some test sites picked out. Now, no matter how high fidelity it is, there's still some uncertainty, there's boulders we didn't see, there's places in shadow. And there might be maybe some noise in the thruster that it doesn't thrust exactly where it should, and it ends up a little bit off course. So we have to plan for those contingencies. And so it's a lot of simulation based. Now, once we get the simulations working, we do have some things like a gravity offloader. I'm not sure if you guys have gone to SwampWorks or if you're going there, but if you get a chance, it's a great place to go. They have a big lunar dust bin and a gravity offloader that simulates lunar environments. That doesn't have thrusters in it, right? It's just a big dust bin, so we don't want to fire rockets inside of a closed room like that. But we can simulate the dynamics and the resistance that would be generated by a thruster. So there's a lot of different ways we can test these things, and we do all of them.
thank you.
Other questions?
What are some of your favorite supply chain or logistics facts for deep space?
Supply chain logistics fact. You know, we went to a conference in 2019. It was the Air Cargo Conference, and that was in Nashville, Tennessee. They put us in the Omnia, which is the nicest place I've ever been on a government dime. So I tell you, it's not usually you're in a Holiday Inn or something like that. We were in the Omnia, and it was attached to the Country Music Hall of Fame. And all these guys in the logistics did this conference about air cargo and logistics. They were all rather well. One guy was giving away bottles of his own homemade bourbon brand. It was nuts. And so it was kind of interesting to be in touch with that crowd, because usually I'm more with the academic crowd. And so meeting these people and getting their perspective on what logistics looks like for the closest analogy we have, air cargo, moving things from one place to another, was kind of eye-opening. And they were at first kind of confused, why is NASA talking to us? But once we kind of said, we want to do what you do, but in space, it started to make a little bit of sense. So I'm not sure if that's really qualifies as the most interesting, logistics fact. We still don't know how to do logistics in space, because everything's moving, everything's changing, and you can't have a set route, right? You can't have a set subway line. There's always some ambiguity.
Are there trade lanes in space? Are you establishing maybe trade lanes or trade routes in space?
Yeah, so, everything's moving around everything else. So a trade lane that might work one day isn't going to work the other day. So take the Voyager 1 and 2 spacecraft, for example. When Voyager 1 and 2 spacecraft were launched, there was this once-in-a-century alignment of planets where you could just get flyby after flyby after flyby. And they figured this out, and they loaded up on the rockets and launched as soon as possible. And so that alignment won't happen. It's about to happen in another 30, 40 years. So we're thinking about doing it again. But when they launched, it was just this perfect alignment. So you can't have a supply chain that consistently goes to, let's stop off at Jupiter and then stop off at Saturn and then stop off, because there's just not enough fuel to do that right now. We need a new technology to enable that kind of delta V. And so, how many of you have seen The Expanse? Yeah. If you haven't, you should watch it. It's excellent. So you can see that the big change in the Advance was when they all of a sudden discovered this new drive that ended up killing the guy who made it, but it was so powerful. It could accelerate so quickly on so little fuel. I forget, it's like an antimatter drive. I don't remember what it was, but it was completely game-changing. We need something like that to have these supply chains, to have these regular service to and from Mars, or to and from wherever. But until then, that regular service to and from Mars is every 2 years, 2-point-something years, because that's when Mars and Earth have the right alignment for Hohmann transfer.
Brokering success demands a battle-ready strategy. TIE TMS equips freight brokers with the ultimate battle station for conquering a tough market. With TIE, brokers gain access to a comprehensive platform where rate intelligence and quote history converge on a single screen. It's not just a page, it's a strategic command center designed to help brokers win. TIE equips your team with all of the data they need to negotiate with confidence and allows them to communicate directly with carriers and customers from a simple control base. Revolutionize the way your brokers perform by giving them a competitive advantage with TIE TMS. For more info, go to tai-software.com/battlestations, and we also have a link for you in the show notes to sign up for a demo. Is there anything you learned from the private sector of air cargo, that conference, that you apply at NASA?
There's a lot of things about, it was a lot to do with cargo packing and how they manage different shaped cargoes in different iterations. So a lot of the stuff with ISS is pretty standardized. We've had it for 20 years. We resupply pretty regularly. So we know what we're doing with that. We have specialized software that fits the optimal configuration to get the most volume, because we end up being volume limited before mass limited. So if we can deliver 10,000 pounds or something, we can only fit like 8,500 before we're just packing it in, right? So they have this software that optimally fits everything together. But if we want to do different cargo, if we want to take on one load, offload, and put it in another one, and do it pretty rapidly, it takes up a lot of astronaut time to fit this stuff into place. So we're learning a bit from the industry about how they do their loading and unloading and handling these changing loads in order to best accommodate a variety of customers. And so that's something we've taken back, and we had a bunch of crowdsourcing challenge where we reached out to universities and even high schools and said, what do you think we could do to best manage our cargo? And we have all kinds of really interesting ideas. We have a automatic cargo loading and unloading system with like cheese wedge shaped boxes. It was pretty cool. And that was by the University of Michigan, University of Michigan. And they did a really cool job with that. But that's just one of many. So it's just collecting ideas right now.
Michigan
Wolverines rule, okay.
Based on the, oh, sorry, did I steal somebody's question?
Yeah, I'm going to go with this guy first.
I was going to ask, what excites you the most about all of this?
So I come from a background of academia, and so we've worked a lot with publishing papers and writing down. It's a lot of math, right? And my advisor was very much an academic, focusing on, it doesn't matter if this can be applied today, it matters how revolutionary this will be in 100 years, taking the Einstein approach to things, right? But I'm really focused on getting this stuff, because we're publishing so many papers, it's such a big talented academic community we have in the United States and around the world. Making that into hardware is a huge challenge. So what excites me the best is when I take this theory and I say, let's try to do this, and everyone tells me how bad it is, or how many ways it won't work, because that's a whole list of challenges that just adds a bunch of nuance, many different layers of nuance. I might have a simulation that works great, but as soon as you start adding noise, it starts behaving unpredictably. So that's what excites me most, when I come across a practical, real-world problem that people are like, no, you can't solve that. It's like, well, let's try anyway. So, those kind of challenges.
Going back to the expense that you brought up and this super material that could just propel us into this trade belt,
Right.
Based on your experience and expertise, what are your predictions?
It's nothing quite that exotic. Our next step is nuclear thermal propulsion. And it's not actually a new technology. We've had this in some form or another in the past 30, 40 years. I forgot the name of the project, and it was canceled in the 80s or 90s. But it was a nuclear thermal propulsion device. And it's pretty much the next step we need in space. So that can cut down our Mars transit time in half. It's probably what we really need to get off the ground. Fortunately, we're working on that now. Our Mars transit vehicle should have a nuclear thermal propulsion device.
By when, do you think?
Ask Congress. If we have a continuing budget, then we can get it done pretty quick. The biggest challenge to NASA is every 4 years our priorities change. We need to be insulated from that.
And assuming NASA, the government approved NASA's budgets, when would that? How long to?
At the soonest rate, if we were back up to Apollo budget, which was 4% of GDP, by comparison, we're 0.5% of GDP right now. Or sorry, 0.5% of the budget. If we were back up to 4%, we would already be on the moon. Again, we'd have a base, and I think we'd be thinking about Mars.
Wait, you said it was 4% of the GDP during Apollo.
Correct.
And now it's...
It's 4% of the national budget,
yeah.
GDP. 4% of the national budget, and now it's half of 1%. So it's 1/8 of what it was during Apollo. So
So it just kept getting lower and lower.
So launch rockets.
not necessarily lower and lower. It actually got cut after Apollo, and it got cut a couple times, and then it's pretty much stayed there. So it stayed at about 0.5 or 0.5% of the national budget for a long time. And during that, with that very small percentage, we have ISS, we have SLS, which is not the best rocket in the world if you compare it against Elon's Starship, but with 0.5% of GDP, 1/30th of what the DoD gets, we still managed to do that. We're still trying to go to the moon. So,
Well, and that's also why they've been putting so much into low Earth orbit, that we have the commercial partners
right,
and everybody that's buying it.
it's precisely true. So if we have a very talented commercial industry that can lower the price, which is what exactly they've been doing, then that enables us to go forward.
All right, just popping back in to list out a few takeaways that I thought were really interesting. One, which is Matt, when he says, we still don't know how to do logistics in space. I thought that was really interesting, that they are still learning how to do that entire process. Another one was obviously the air cargo conference that they attended back in 2019, where they were, learning from the private sector on how to, better pack their own rockets and transporters and all of that good stuff. Another thing, if you were watching the video version of this conversation, then you might have noticed a gentleman in the background walking back and forth and fixing something. Well, that was actually a NASA engineer, and he's walking back and forth as if he doesn't have better things to do, but he just notices a tiny detail that is messed up within his working space, and he has to fix it right away. So I love that mindset, because there was like a small light that was out in the display case, and so he has to pause his day and make sure that thing gets fixed, so it represents his program that he works for, the Deep Space Logistics program, that it is represented properly, because do have to give him credit. The light that was shining was on the Deep Space Logistics logo, which they have a really cool logo. Hold on, I will pull it up. All right. And another thing that I wanted to bring up, because there's so much to digest from this trip that I just keep going back into my notes and finding new things that I want to share. And so this was one of the resources that they shared with us on the first day of the tour, actually the first classroom session, from the National Oceanic and Atmospheric Administration, that is the data that they were providing, or the insight that they were providing, not data too, that they were providing in the first classroom session on day one of the 2-day tour. And obviously this is a Deep Space Logistics episode, so let's talk about a little bit of the logistics of this satellite that is going up into space. I'm obviously going to get into more details on that specific episode, so if you're interested in everything that goes on within launch day, make sure that you listen and watch that particular episode. But for this one, it's just a really cool, just like photo gallery that the NOAA creates for all of their missions, and they go behind the scenes on everything. So it's really cool from a transportation perspective of basically shipping this satellite over to Cape Canaveral and getting it ready for launch. So on this blog article, which I will share in the show notes in case you want to download some of these images, because they have the download option right on their site. So they talk about the satellite itself and shipping it. You can see it here in this photo. It's a U.S. Air Force plane that shipped it, and then it looks like a Chevy truck that is pulling it out of the plane itself. And if I read a little bit of this about the shipment to the Kennedy Space Center, and it says on January 22nd of 2024, the GOES-U team carefully packed and shipped GOES-U from a Lockheed Martin facility in Littleton, Colorado, where it was built, integrated with its instruments, and tested to a facility in Florida, where it arrived on January 23rd and will undergo final preparation for launch. They say shipping a satellite is no small feat. GOES-U is the size of a small school bus and weighs over 6,000 pounds. And after packing the GOES-U in a high-tech shipping container that acts as a mobile clean room, a crew drove the satellite to Bucky Space Force Base in Aurora, Colorado. Still can't get over the fact that we have a division of the military called the Space Force, which they actually kind of have a really cool logo. But the article goes on to say that they loaded into a C-5M Super Galaxy cargo transport. Also, in crazy names. Space Logistics really has like the most fun like branding. Space Force, Super Galaxy, Cargo Transport. But the next stop was NASA's Kennedy Space Center in Florida. So if we scroll through, and as I'm scrolling through on this webpage, Jesus, is it 1990? This website that is also linked in the show notes, they talk about that entire shipping process. I don't know that I'm going to go through it and read all of these. I feel like, if you want to read it, you can go through and read it yourself. But as I come to the end where they actually show the satellite that's inside of the launch vehicle, which is really cool to see because and as I'm scrolling through, you can see the launch vehicle being attached to the rockets, which is the Falcon Heavy with the double boosters. The Falcon Heavy is one of the rockets by SpaceX, and then it has the double boosters on the side that are infamous for detaching from the rocket and being able to land at the same time, or not damn near close to the same time, but they take off with the rocket and then they detach and they land on their own launch pads after the fact. So that is the satellite being attached to all of that before it actually takes off. So obviously they've gone back through and updated this website with this post with some of the images after the launch was successful. And so hopefully you enjoyed a little bit of that scroll through the transportation process, because it's quite funny to see one of these launch vehicles, because I think it was the first day that we were at the NASA tour, this is just sort of, a little bit of a sidebar. We were going from building to building and checking out, just different parts of the tour. And on one of the stops, because we would literally just, drive out of one building and it would be a 2-minute drive to the next building, and we would park over and get out and do our thing. Well, on one of these pathways, and one of the times that we were doing this, there was another one of these vehicles for a Starship, or not Starship, it was for the Starlink satellites, Elon Musk Starlink satellites. There was a Starlink launch the very next day, and so a rocket, or I guess what do they call it? The launch vehicles that carries all of the Starlink satellites, which the GOES-U satellite is significantly bigger. Like we just heard that it's the size of a small school bus. That the Starlink satellites are not as large as that, and so they there are a lot of them that are sent up in a Starlink transporter mission, and so that was blocking the roadway. And hold on, I will bring up that clip right now. And here's that video of that rocket actually causing a traffic jam for one of those routes that we were taking. And then one more last thing I definitely wanted to show everyone is we talked about the rocket boosters, that both of them come down. And so for one of the creators that I follow over on Twitter or X, he actually posts a lot of these photos and the barges that ship, different launch pads. And I guess it never really occurred to me until this trip of just how often rocket launches are actually taking place. And as a Floridian, you maybe 2 or 3 times a year growing up, but over the last few years, it's like 2 or 3 a week now. So it's happening very frequently. There's also 22 total launch pads, I believe. And so for a lot of construction that goes on for launch pads, or as they're getting replaced, they have to ship those things in. And so it's really cool to be able to see some of these images. And that one of this image comes from C. Nunez images over on X. And this is one of the launch pads that are being shipped in, and it's being constructed. There are a few other images here. We talked about the rocket boosters. You can see one of the rocket boosters right here. Like, isn't that incredible that this is essentially a barge that is built for the rocket boosters to come back and land on? Let me see if I can get rid of this. Then there are a couple just more images that I wanted to show for, we're tugboat respecters over here. So a tugboat pulling the barge with one of the boosters that are on it. This comes from Jerry Pike over on X. And I just think these are incredible images, that these are the boosters that are landing, responsible for a rocket taking off. And then all of a sudden, they're responsible for these boosters landing back on them. And you got the tugs pulling the barges, going right back into the Port of Canaveral right there. So just really, really cool stuff. And just, for me, it's just, I think it brings it all home about how much logistics really goes into this entire process. We're still trying to figure out new ways and cool ways to do logistics here on Earth, and to know that in space, they don't exactly have it all figured out yet. And you have some of the smartest minds in the world and human history, really, that are trying to figure out these complex problems, and they're going to a variety of sources to try to get those answers. So it's just just really cool stuff all around. So I hope you enjoyed this deep space logistics episode. This is a reminder that we have several episodes in this series, I believe 5 to start with, and then we'll start scheduling some interviews in the future with some of the meteorologists that we met, some of the forensic meteorologists that were on site to talk about, different weather patterns all across the United States, how that impacts the shipments of goods. And then we will also be talking about talking to some of the experts, hopefully Matt included. We're trying to get him on, a future show so we can ask him some more logistics focused questions. So all that to say, hope you enjoyed this episode. Be sure to check out the other ones and hit the link in the show notes in order to watch the video version of this or to see other videos as part of our space logistics series. So thank you guys again.